let's go over basic circuit theory. Say there's a little guy standing on the table, which is on the floor. If he jumps off the table, he lands on the floor. It's a little energy created due to gravity. Okay? Say the floor is plate 1 and the table he's standing on is plate 2. The difference between those two plates is the amount of energy that's going to be created. Say he's standing on a big building, tall building, he's on top of the tall building. If he jumps off, that's going to create a lot more energy. Say the ground is still plate 1 and he's standing on top of the building, plate 2. The difference between those two plates is going to create a lot more energy. Same thing happens in a battery, say a 9-volt battery. You have a little terminal on top and a big one. The little one's ironically positive and the big one's negative. They have two plates going down into the battery you can't see. And the battery is filled with chemical that stores the energy. So this positive is trying to make its way to the negative. But it can't because there's no space there. There's nothing connecting them to. Say we have a C or D type battery. Or we could say, we could still call it 9 volts. Okay, the battery looks like this. The top with the terminal is a positive, and the bottom is negative. Say we have a resistors. We have a wire, a simple wire connected to a resistor, say R1, with another wire and a resistor, say R2. Okay, basically this is a circuit. Circuit comes from the word circle. Now, positive is trying to get to the negative, so it's going to go through the wire, through resistor 1, through another wire, through resistor 2, through another wire, and come back to the bottom of the battery. Okay? And thus, it has made a circuit, a circle. Okay? The resistors, first of all, let's go over this. Say there is water with a current flow of water. Okay? How fast the water flows is called current. Current is how fast something flows. How fast something flows. Okay? River, it's how fast water flows. In electronics, say a wire, it's how fast charge flows. But it's still current. In electronics, current, in a car, you have how fast the car goes is miles per hour. In electronics, it's amperes or amps. Okay? But that's basically how it works. A resistor, by the way, resists the flow of the river. Say you have a funnel. It would slow it down, right? It would resist. So that's what a resistor does. It resists the flow on a wire. Makes this huge thing goes up, down to resist it. So that's what resistors do. And if you have like 9 volts, a resistor drops the charge. So now, say this one drops it to 5 volts. And this one drops it to 0 volts. So that's what each resistor do. It drops, okay, according to what it does. So this one dropped it by 4 volts. 9 volts dropped 4 volts, give you 5 volts. And this one dropped 5 volts to 0 volts. Okay, so we can calculate a lot of voltage by E in volts equals I times R. I is current, R is resistance, E is voltage. And like miles per hour, E is in volts, current is in amperes, and resistance is in ohms, spelled O-H-M. Okay? And P is power in watts. It's in watts. Power is in watts equals I times E. You can calculate that. Since we know E is IR, we could say equals I times IR, which we can shorthand called I squared R. So that's how all that works. And that's basic circuit theory. There's a lot more, but this is everything that you really need to know.